this is the most challenging related rates problem that you could get. We call it related rates. Why do we call it related rates? Because if the area of a circle is changing, what else is changing? The circumference, radius, diameter. What's the other thing that's changing?
Rates.
What's the other
Surface
thing
area.
that changes?
Time.
So everything changes is related to time. Related rates. They're all related to time, thus related rates. So we've said related rates enough now. You know that this unit is about related rates. And so in our related rates of change, an inverted conical tank, inverted means upside down, we are filling it with none other than H2O, which to the common folk is water, or Spanish people, agua. And what we know is that this tank, it currently measures 24 feet tall. And it measures 20 feet wide.
Do you have any Kleenexes?
I don't, I'm sorry. Are the dimensions of the tank changing? No, those are constant. We're not wondering how the tank is changing. We're wondering how the water level is changing. If we're dumping water in at a rate of 10 cubic feet per minute, at what rate is the height of the water changing when the water has a diameter of 12 feet wide? Okay, everybody agree this looks like a challenging problem?
Yeah.
Let's sort through it, and as we sort through it, obviously we're going to need the volume of a cone, which is 1/3 pi r squared h. What do I know in this problem? What is my givens that I'll make use of?
The radius and the height. Radius being 10, diameter 20, right?
Yes. Ben says that the radius is 10, the diameter is 20, but that's of the cone. The
We're looking
cone
at
is
the
not
water.
changing.
Oh.
So what do we know about the water?
The radius is
Wow.
6. The
Radius is
diameter
6.
is 12.
Diameter is 12. We know that. What else do we know?
The rate is being filled at 10.
And we call that volume, or we call that variable
Volume prime.
V prime is equal to 10. Good. Excellent.
Thank you.
All right.
We have to find the
So,
height prime.
yeah, we need to know H prime. Excellent. So we've really kind of narrowed down what we want within this problem. We want the H prime. We're going to work towards this. We got volume is 1/3 pi r squared h. You recognize if you were to take the derivative right now, this would require the use of the product rule, right?
Yeah.
And the problem with the product rule is that we would come up with r prime and we'd come up with h prime. H prime is what we're trying to find. We have no ability to calculate r prime. So therefore, we must get rid of either r or h. And because we want to come up with h prime, we're going to get rid of r. What can we do to get rid of r? We've
Plug
talked
in
about this.
R.
D times
Isolate.
1/2.
Then that's a great idea, but then we would come up with d, and we got no way of calculating d prime.
Oh.
Isolate it and then
Plug in the R.
How isolate? How?
You divide it by 1/3 pi h.
Okay, excellent idea, but
Wait,
so if you do
you're
that,
right.
that's circular.
Don't we have R?
Can't we plug in the
6.
R?
Is r changing?
I don't know.
Is as you're
Yes.
filling water, is the radius of water changing?
Oh, yeah?
Yes.
Oh,
Oh,
so you can't plug it in.
What we know is that the water, it fills the cone,
unchanging.
and it's
cone.
always within the same shape, meaning that the radius and the height are always in proportion to one another. Remember we did that the other day?
Yeah.
What is the radius of the cone?
10.
10.
Oh,
And what's the height?
24.
24. So that means that the water will fill at that same ratio. The ratio of the water will also be 10 over 24. As I cross multiply, I get 24R is equal to 10H. And now as I divide by 24, I get R is equal to 5/12H.
Oh, so you can just square that in thing?
Now I drop that in here, exactly. Volume is 1/3 pi. I'm going to square that and get 25/144
H squared.
times H is
Cubed.
H cubed.
Wait, why is it H squared times H?
Because I'm squaring this, and this will produce an H squared.
Okay.
So I have the derivative with respect to time of B equals, if I multiply by 3, I get 25 pi on top and 432 on the bottom. And again, we see within our related rates, we have the t variable on the bottom, thus we're using implicit differentiation. The derivative of b is b prime. We put the 3 in front, we get 75 pi. That was amazing.
Wait, since you brought the 3 out to the front and the top one should
Oh, I'm sorry,
be H
75,
squared.
75. Sorry about that. So I haven't taken the derivative yet at that spot, so I am going to go to h squared.
So how did you get, oh, you just multiplied the 2.
Yep. And then I have h squared and h prime. So in this problem, I know that b prime is 10. I have 75 pi over 432. H squared. Shoot, I don't know the height. I know the relationship. And if the current radius is 6, I can figure out the height, can I?
Yeah.
If I multiply by the reciprocal, I get 72 over 5. We're going to square that and multiply by h prime. Now I have enough information to be able to calculate h prime. Gunnar? So I took the radius, which is 6, plugged it in here. I multiplied by 12 to get 72. I divided by 5 to get 72/5. We'll pick up with that when you guys get back from lunch. Please go fill your bellies with good stuff. If anybody finds a Kleenex for Nevaeh, that would be awesome.
I'll get mine.
Or here, actually, I might have one.